This is how you can scrape any website into a vector database for your AI agent in n8n without any coding required. So our goal really is to be able to extract the content within any websites of any companies and be able to actually store them in a vector store so that we can use an AI agent to do a RAG later on. So again, without going too technical about what those terms are, essentially what you're doing is you're saving these kind of website data into somewhere in a database so that your AI agent can actually reference those information, use the information that you stored, and actually generate a response to the users as a almost like an FAQ or question and answer agent. So let's get straight into it. We start the workflow by testing the test workflow, and we're actually going to get the sitemap. Now, if you're not familiar, any website will have a sitemap. So if I literally just go to local restaurants, and yeah, if I literally click here, if I go to website, if it has a website, doesn't seem so. So we go to the next one. Yep, it does have a website. So it's mychicken.hk, right? So if I just click /sitemap.xml, that was not found. Okay, so apparently that's not something. So I've already found another website that already has sitemaps. So if you just click /sitemap.xml, you can actually see the directories or the URLs within this sitemap. So for example, this is another restaurant that I found kind of beforehand, and you can see there's a big bunch of URLs. For example, the appetizer, starter, snacks, donuts, salads, curries, pizza, burgers, drinks, whatever, right? And all these different categories, these are different URLs. Well, we want to be ideally able to actually scrape the content within all these URLs. So in order to do that, what we actually need to do is, first of all, we need to get the sitemap. And the sitemap is just this one. So I just copy this sitemap. I'm going to paste this in the HTTP request node, paste here, and after when I test this step, it should be able to retrieve the information from this sitemap. So it's running at the moment, but as you can see all these XML data from here. Now, after you get the sitemap data, you should be able to turn the XML sitemap data format into JSON format, right? Because JSON, well, it's just easier to work with. So this is the XML that you just extract by sending an HTTP request to actually extract the website content from the sitemap content from the XML, and now you want to turn this into JSON. So the way you do that is you select XML to JSON, and the proper name you select data because, well, you want to actually turn this data tag here. You want to turn the data within this data tag into JSON. So if we literally just test it now, it will actually output all the URLs, right? You have the first URL, starter, snacks, donut. So that actually corresponds to the URL. So all we're doing here is just we pre-process the XML data and we are outputting all the URLs in here, right? I hope that makes sense. And afterwards, then we turn the URL array into multiple items, right? So what we do is, because you have one data block in URL, what you actually really want to do is you want to split it into multiple URLs. So that's why you use the turn URL array into multiple items. If you use this step, it returns 13 items, right? So if you can see the JSON, you can basically return 13 different items. Rather than just having one bundle of URLs, you actually have one item, you're actually splitting it into 13 items. Now, the reason why we want to do that is as follows. We add a loop over items node, right? Loop over item nodes. Basically what we want to do is we want to loop over all the URLs that's being outputted in here. And within each URL, we want to get the pages listed in the XML. So we're trying to essentially, if I literally click test step, is within this kind of URL, we're trying to get the web pages within like this specific website. So if I literally just show you the data, yeah. So essentially, we have the URL. but we want to extract the content, the HTML content, which is the website content within this URL, right? So as an example, to make it a little bit less abstract, if I just open link in new tab, you can see that, well, I want to know there's like maroon steak, there's samosa, there's fresh cut chips, right? Fresh cut onion rings, etc. But what I want to do is I want to get all these data, right? So what I actually can do then is by using this step, this HTTP GET request, I was able to extract the data of this specific the appetizer starter URL. I was able to get all these content. Now, this is just going to repeat loop over the items of all the URLs that you extracted. So it's going to repeat 13 times, right? Because you have 13 URLs. Each URL, you extract the HTML content and save it into variable. And the reason why it's wait 5 seconds is because, well, for this case, it's not really relevant for us because it's only like 13 URLs. But you can imagine if you go to something like apple.com/sitemap.xml, well, that's like not 1 million, but like thousands of these URLs, right? Uh, so the problem is if you actually do that without waiting 5 seconds, when you just automatically do it 1 second, 1 second, 1 second, almost instantly, they're going to block you because basically what you're doing is you're trying to make a request. Every time you run this, you're making a request to the server, right? So imagine if you're making 10,000 requests in like 5 minutes, they're going to flag you as trying to like DDoS attack them if you're familiar with the term. Basically, you're sending way too many requests in such a short time. You'll try to overwhelm the server, and they will basically think that you're trying to like disrupt the service and things like that. So they will definitely going to be like blocking your requests. So then you can't scrape the content anymore. So that's why we add the wait 5 seconds just to be safe. So as you can imagine, if it's a 10,000 website, it's gonna take forever to run this. So, but for our case, it's quite simple. So this is still manageable. So after it extracts all of the HTML, all of the HTML content, what it does is that we actually want a way to be able to extract, because right now it's, you can see it's, yeah. Wait, if I show you the JSON, it's a little bit laggy right now, but you can see it's like a bunch of nonsense, right? This HTML content. Well, we actually don't need anything because, for example, we don't need to know about the fonts. We don't need to know. There's so much thing that we don't need to know about the link, right? Because if you go back to the website, it contains a bunch of the styling things that we don't care about. We just want to know what are the different appetizers, right? The fresh cut onion rings, chips of cheese, spring onions, etc. Right? Well, I want to get these data, not the styling. Like I don't care what color this website's in, right? So I want to be able to extract the main content within the HTML links, right? So the way that you do that is actually, well, I want to be able to go to the website, right click, and click inspect. Now, you might be, okay, you can't see me, but if I actually just do this again. Now, don't worry too much. This is literally just the HTML. This is exactly the HTML, by the way, is exactly what you just extracted through the get HTTP request by retrieving that content. Now, if you literally go here, I want to be able to extract the main content, right? So if I literally just look through this kind of HTML script, usually it will have something called like div main to represent the actual like data. But for now, if I literally just go down here, you can see suggested product list. If I scroll down here, you can see there's different like links. If I get to one of them, you can see the suggested product image, suggested product content, etc. Right? So this is what we actually want, and we're going to extract from the HTML the content of that specific tag, which is the suggested product data. After you extract the HTML, what you actually want to do is that you want to aggregate all, because remember, there are 13 different uh, the 13 different URLs, and therefore there will be 13 different web pages, and you will have 13 different, well, content. But you want to actually aggregate all of them and store them into a vector store. Now, this is very important. Now, with if you're not familiar, if with kind of AI agent, how kind of the AI agent actually is able to work with a knowledge base is that you actually save all this information in something called vectors, which are just numbers. Think of it just numbers. If you're familiar with it, great. If you're not too familiar with it, just think of it as numbers. It's a way for the AI to be able to actually read the data because AI can't read English, right? So what it's actually doing is it breaking down the words or the text into a numerical representation. So this is actually what's happening. And in order to do that, you actually need to go to something called Pinecone. And I've already set up the account, but literally all you would do is if you go to app.pinecone.io, you will have your own organization. So you will basically have your own API key. If you just click generate API key, I've already done that, so I'm not going to do that. But within here essentially is where you can set up your own vector store. So if you go to database and if you can create index, and you can just create a name like test2, and you can configure it doing different embedding models. Now, personally, I would just stick with the OpenAI ones. For this one, let's just stick with the text embedding 3 large. You can choose. Really, I would just go for the OpenAI like small and large. Again, depends on use case. So all this does, if you remember what I said about vector embedding, is it turns text or characters, specifically it's tokens. But if you just literally imagine them as words, if you were to translate them into numbers, numerical representation, this is what the text embedding is doing. It's translating words into numbers, into vectors, which is a numerical representation. Now, don't worry too much about these settings. Just thing to remember is that its dimension is 3072 of the vectors, and it's a metric cosine. Now you can do dot product or cosine, but cosine is just a way to kind of measure how similar the knowledge base information that you received are to the user's question. Again, don't worry too much about this. It's just a similarity scoring. So this is just a way to measure how close your retrieved knowledge base chunks are to your questions. So just click on, for you guys, so just click on text embedding 3 large. And now you just choose a cloud provider, just stick with AWS. I'll just stick with Virginia, like where's you host it, it doesn't really matter. And if you just click on create index, now you will have to create your own index, right? So again, now you've done all the work within Pinecone, within n8n, all you literally have to do is you just create a Pinecone vector store, you connect your API account, you click on insert documents because you're trying to insert information into vector store, right? And within the Pinecone index, you literally just click on a list. Now you have test and test2. Well, I just created the test2, right? Test2, that's its name, test2. And yeah, that's it. That's literally it. And you will need to also set up an embeddings, but it should automatically fill in with the one that you chose from earlier, which is text embedding 3 large, if you remember. Remember, the embedding is just translating the words into numbers. The default data loader you will need is because this is where you actually load the data. You load the documents, which in this case will be the website content, and the way that the vector store able to take into these kind of letters or this content that you generated is through the data loader. And text splitter is basically a method where you can feed those data into the Python vector store. So just if you're not too familiar with it, don't worry too much. Just imagine this is a way that the AI is able to take in the information that you feed it and turn it into numbers or numerical representations using a embedding. Now, we just use something called recursive character text splitter. This is kind of the way that I like to do it. It's just a default way that I like to use it. There are different algorithms if you want to look into it. I'm not going to go into it. Like you can just Google different text splitter methods if you want. But for me, I just like using recursive. And once you actually load the data into it, now you should have all the setup done. Now you just click save, and yeah, and from now on you can just test workflow. And it should take a while to actually load all the different URLs and actually load this into the Pinecone vector store. Oh, you said the server is temporarily busy. Maybe I've tried it so many times already, but this is actually really funny. See, that's the thing, guys. Don't use it too much. Okay, it's okay now. But like, yes, don't try. That's why I used to wait 5 seconds so that it doesn't register me as someone who's trying to attack the server. Cool. Now, if you this should have finished loading, if you go back to the Pinecone database, as you can see, if created the records, you have different IDs. And it's saving all the different product images here. So if you can go ahead and see, you've got the roasted lamb supreme. Okay, someone purchased a roasted lamb supreme. Okay, cool. Good to know. Of course, I'm just using kind of an arbitrary example, but like you guys, go ahead, use any websites you want. I don't recommend you to use something too big like Apple, but like just any kind of reasonable kind of size websites, you can just try it, and yeah, that should be able to scrape all the content you need. Scrape all the content you need, and now you can now actually use a chat agent. So you can just have a question and answer chain within n8n, which you can just set the chat trigger to be, well, chat input, which is the chat trigger here. So what this question and answer chain does is actually just acts as a Q&A FAQ agent, and it's using the OpenAI model. I'm just using 4.1 mini. You can just use whatever you want. You can use 4.0 if you want. Let me try to find 4.0 if I can. There you go. And it's using it's using the knowledge base that we just set. So if you just go to vector store retriever, Pine is going to store vector. If I just select back test2, which is the one that we use, you don't actually need the namespace for it. You can just leave it, to be honest with you, test2. And yeah, then you're good to go. And the embedding should be automatically set to the embedding large, which is the original one we set for Pinecone. And now we can just open chat and just ask it question. You literally just ask something like, what did someone just order? Someone just ordered a roasted lamb supreme, right? Which is actually what's what's in the pinecone, right? Someone just ordered a supreme lamb supreme, right? Okay, cool. So yeah, this is kind of a risk. To be fair, this is not the best example in terms of like the sitemap. It's like you would if you want to do this, you would probably want to use some sort of like a product database that you have set up properly in the website. I think that would be even better. But yeah, but then again, this is just to kind of show you the example of like it's using the content that it just scraped and be able to answer questions based on the questions the user asked. So hopefully this has been helpful. You can set this up yourself to any website, and you should be able to answer questions or do some sort of Q&A questions based on the vector store. Hope this helps, and I'll see you in the next one.